Welcome to part 3 of learning the basic derivative rules. In the previous episode, we learned about the product rule, the quotient rule, and the chain rule. In this video, we're going to learn the exponential functions, the logarithmic functions, and the trigonometric functions. First, we're going to begin with exponential functions. So, exponential functions are e to the x. And the general formula for that is d dx of e to the x is e to the x. It can't be moved. But let's say there's a function in x, so it would be d dx e f of x. It would be equal to the derivative of f of x multiplied by the original function. You just copy this, and then you take the derivative, and then you're going to multiply it by e. Using this general formula, we can solve for exponential functions. First example, find the derivative of e to the x. The derivative of e to the x will always be e to the x. For our second example, find the derivative of 3 e to the x. It would be the same using the constant multiple rule. If we multiply by 3, and then e to the x is still the same. We're going to find the derivative of e to x squared. Using the formula, we're going to find the derivative of the function above here. We're going to take this. We're going to find the derivative. The derivative of 2x squared is 4x. And then we're going to copy the original function. And then we're going to multiply them. It would be 4x e raised to the 2x squared power. And that's our final answer. Now for our logarithmic functions, all you have to remember is that dx, the natural log of x, will be 1 over x. And the general formula, if ln is a function inside of it, then all you have to do is take the derivative of the function inside, and we're going to put it over the original function. Let's have some examples. D dx of the natural log of x would be 1 over x. If you find the derivative of 5 ln x, it would just be 5 multiplied by 1x, and it would be 5 over x. What if you want to find the derivative of the natural log of 3x squared plus 1? First, we're going to put a fraction. For the numerator, we're going to find the derivative of what's inside the natural log. The derivative of 3x squared is 6x. The derivative of 1 is 0. And then we're going to copy the original function for the denominator. And that's our final answer. And for the last one on our video, we're going to talk about the trigonometric derivatives. To memorize all 6 of these trigonometric derivatives, then we can solve. Always remember that if the function starts with a c, then its derivative would be negative. The function starts with a c, it would be negative. And the other one would be positive. For our first example, we're going to find the derivative of sine x and turn it into cosine x, because the derivative of sine x is cosine x. Another example, what if we find the derivative of 2 cosine x? We're just going to take our constant, and we're going to find the derivative of cosine x. And it would be multiplied to negative sine x. And we're going to multiply negative 1 by 2. So it would be negative 2. And then we're going to multiply it with sine x. And it would be the final answer. And for our last example, we're going to find the derivative of tangent 3x squared. this is a chain rule function. This is a chain rule. So what we're gonna do is we're going to find the derivative of tan. What's the derivative of tangent? The derivative of tangent is secant squared x. So we're gonna go back. We're going to put secant squared, and then we're going to copy everything inside the function, so it would be 3x squared. And then we're going to multiply it by what's inside the function, which is 6x. We're going to multiply these two. It would be 6x secant squared 3x squared. And that's our final answer.